Kscope 2015 in Florida.
Good morning, everyone. Ooh, I'm kind of loud in here. I'll just speak softly. I have a presentation for you today on analytical SQL functions. Of course, I was going to do all live demos, and of course the network will not connect to my database from here. It works from upstairs, but it will not work from downstairs, but that's okay. Because if you log onto your ODTUG website and go in where you download the presentations, I have put a file there with every single demo code that I was going to do today, and you can run those against the sample tables that Oracle provides, the employees tables and the orders tables. So when you get back, you can run these for yourself and see exactly what the output looks like and play with it. Okay, so being from an education institution, that's sort of a requirement for us to do that kind of thing for anyone and everyone. Also, if you want extra information about any of this material, strangely enough, it's in the Oracle Data Warehousing Guide, and it's chapters 18 and 19 in the Data Warehousing Guide. It's a strange place to put SQL stuff, but that's where you'd find it. Okay. Chapters 18 and 19. Yeah, so that, sure. Their examples, let me warn you about all of their examples. I find them to be overly complicated. When you can do an example on a single table and you do a 4-table join in your example, I consider that overly complicated. So every example that I have, I whittled it down to its absolute basic essentials in the most simplistic form that I could possibly give it to you, so that you can look at it and you don't have to worry about getting lost in the 4-table join and all of this other stuff, so that you can see just the essence of what the function does. So that makes life a lot simpler. Okay. So again, if you log into ODTUG, you will see the example code, and the example code, as I'm going to show you, will be on every one of these slides. Okay. So let's get started. Well, first of all, how many of you have used any of the analytical functions? Good. Which ones have you used?
Lag and lead.
Lag and lead, good.
Rank, dense, rank.
Rank and dense rank. Anybody use the windowing functions? Really? Nobody's used the window? One, two. Okay. So there will be some new stuff for you to see. Okay. So let's start with roll-up in cube. Roll-up calculates grand totals, and I'm going to show you a trick to know how roll-up works, because a lot of people get confused about what kind of totals it's going to give you. And then cube is like roll-up on steroids. Okay, it does a whole lot more. Let's take a look at the first statement here. And notice that it looks just like a standard group by statement with the word roll-up added right here in parentheses around everything you would find in the group by statement. So select customer ID, order mode, order status, sales rep ID, sum of order total, sum of, actually that should say average, there's a typo, from order total, from orders, group by roll-up. And what it's going to do when it executes is give you totals for each of these 4 things. And if you imagine those 4 things going across, customer ID, order mode, order status, sales rep ID, it's going to give you totals for those 4 things, and then for the first 3 things, which would be customer ID, order mode, order status, for the first 2 things, customer ID and order mode, and then the first thing, which would be customer ID. Okay? So if you imagine putting the 4 things across and then drawing a diagonal line this way, the totals get shorter as they go down. Okay? So roll up gives you those kinds of totals. You can also do what's called a partial roll up. And notice here, we've done the exact same thing, except that customer ID is not within the rollup function. So it's not going to give you totals for the customer ID, but it will give you combinations of totals for things inside the rollup clause, the rollup function. So for these three things, then you would get all of the customer IDs, and for those, then you would get combinations of the 3, the 2, and the 1. Okay. Does that make sense? Good, because I discovered that one day, and I thought, if I just remember, put them in a line, draw a diagonal line down to the left, I'll know how I'm going to get my totals out of this thing. Okay? Now, I said cube was like roll up on steroids. Okay? Be very careful, because in the table that I use here, the orders table, there's only about a little over 100 orders in there. This statement will give me over 800 rows returned. Okay? Kind of an interesting result to a query. But what you get is, not only do you get the combination of totals by customer ID, order mode, order status, and sales rep ID, you get every possible combination of those totals. Every possible combination. So you would... I've actually used this. Once upon a long time ago, I worked for Wells Fargo Bank. And we wanted to do totals in any way that you can imagine on a $4.2 billion portfolio. So if someone asked, I want to see a total for, order ID and order status, I could find it instantly. Or order ID and order status and a particular sales rep ID. You can find it. Now, what we did was we would say create table as this thing. And then we'd have a cube. Ours was 16 dimensions, so there were 16 things in the cube clause down there. And then we could find anything we wanted at any time. Okay, and in a minute I'll show you how to find it really fast. Because if you just do a query on that looking for a customer ID equal, there could be tons of totals for that. Okay? And here's how you find it really fast. There is a grouping function. Okay? And grouping only returns one of two values. It returns 1 or 0. Okay? So I have my standard stuff and my standard aggregate functions, and then I put some grouping in here, and those return 0 or 1. If it's 0, it'll tell me it's a total for that guy. And that's important, okay? Because if you don't do the grouping, yes, sir?
You said if it's 0, it's a total.
I
think you mean the other way. If it's 1, it's a total.
You're right, sorry. If it's a 1, it's a total. If it's a 0, it's not a total.
Think of it kind of as a...
Yes. So it's like a little flag. Is this a total or not? And it becomes very helpful, especially when you run a query, and when you have a total, let's say by customer ID and order mode, on that row, order status and sales rep ID will be null, and then there will be another column over there with your aggregate function, which is your sum. Okay? Now, if you look at that, it's very hard to tell, is that really a total by customer ID and a null order status? Or is that a total row? And you can become very confused as to which are actual data rows where a value is null and you're summing it up for values of null, or it's an actual total row. And the only way to actually know the difference between those two things is to use the grouping function so you know which ones are actually totals. Which things are you actually getting a total for? Yes, sir?
Besides the index performance you get by the searching zeros and ones versus actual values.
Tremendous. Okay, what we did at Wells Fargo is we concatenated all those things together so it looked like a bit string. We indexed that thing, and then we could quickly find all of the totals we wanted out of that big table that was all the cube of all that stuff. Yes, sir?
There's a function called grouping underscore ID, which gives you it as a bit string.
That's correct. We did it this way and just concatenated them together. Grouping ID came along after we did it. Okay, so you can tell by looking at those ones which ones are actually total rows. All right. Any questions on cube and grouping? Okay. Again, for those who came in, apologize for not my live demo not working, but for some reason I can connect to my database upstairs, but I can't get to it from downstairs. Different network. That's all right. I can tell you what the code on all of these slides is in a file out there in ODTUG, so you can download it and run it for yourself against the sample tables. Okay.
It's currently available right on the app, all three of your.
Perfect. There it is. Excellent. All right. So you can also use grouping in the having clause. So if you know you're looking for particular totals, you can create totals for just specific things. And here we're just doing it for customer ID and order mode. So all of the other totals would be excluded. Okay? So you can, if you want to, restrict which things that you get totals for. All right? Okay. Yes, sir.
One thing, if you would go back, the restriction there, doing it with having grouping, is good if you are like restricting, filtering away a couple of the possible combinations.
That's correct.
But if you are filtering away quite a few of the combinations, maybe you would probably want to do it the other way. Tell the group by which combinations you want, and then you can use grouping sets.
You can.
Where you explicitly tell which combinations you want. That's like cube on steroids.
Yes. Yeah, some of this stuff you have to be a little careful with. It's like any new toy or tool. Be careful how you use it. Okay. All right. Rank and dense rank. And there is a difference between these two, and it's subtle. Okay. So let's look at rank. And if you've not ever seen one of these before with a clause that looks like this, the first time you see it, it's kind of like, what on earth is that? And I see some furrowed brows, so maybe that's the first time you've seen that. So here we're going to select the year. We're going to select the sum of the salary, nicely formatted. And what I want to do is I want to take those sums and do something with them. And what I want to do with them is I want to rank them, and I'm going to rank them ordering the sum of the salary. And I'm going to order them descending, so the largest is first, and I'm going to put the nulls last. Okay, so it will do your standard group by, no problem there, right? And then it will take all of those sums and it will order them largest to smallest, putting the nulls last, and it will give me back how they rank. Now, this works great until you have a tie. Okay, so let's say I have 1, 2, 3, 4, and there are 2 that are ranked 5. Okay, what's the next one after 5? 7. Okay, because it skips numbers. Okay, that trips people up sometimes. They're like, what happened to 7? Where did it go? Okay, you definitely don't want to give a manager something like that because you know what they're going to say. What happened to 7? You know, my world has ended because 7 is not in the list. So what you can do then is simply change it to dense rank, and you would get 1, 2, 3, 4, 5, 5, 6. So it does not skip numbers. It just continues on, okay? All right, any questions on that? Several of you said, I saw furrowed brows when I pointed out this line before. So have any of you how many of you not seen that kind of statement before? Okay. Yeah, that's something new in the analytical functions. And you have to get used to seeing this whatever over something syntax in the middle of your statement that looks kind of odd. Okay. So to make this work, I actually put an insert statement into that demo script that you have access to. So you can go take the year 2008, you can duplicate it to 2010, so that you can run both rank and dense rank to see how they work when you have things that are exact matches. So the sums are exactly the same. And in this first case here, that's where you'd see 1, 2, 3, 4, 5, 5, 7, 8, 9. And in the second case with dense rank, you'd see 1, 2, 3, 4, 5, 5, 6, 7, 8, 9. Okay. So if you want to try it out on your own, then you can duplicate the data in the employees table. And yes, I was nice, then you can take it out of there to make the rest of the examples work correctly. Okay. Any questions over rank and dense rank? Yes, sir.
Yeah, so, excuse me, with dense rank, does it just decide itself how to break the tie? I mean, in order, it's still got to list them in some order.
Yes.
Yeah.
But 6 is the same as 6.
No, I understand that.
I mean, 5 is the same as 5.
But sometimes you would want, for example, a sub-resolution of that, like is there possible to do that in some way?
Not with that function.
Okay, that was my
No.
question.
Yes, sir.
The question was how does it break the ties? Well, it doesn't break ties.
Correct.
Those that are ties get the same rank.
Yeah.
Oh, I
Both with rank and dense rank.
Yeah, I understand that, but my question is, if you want to say inside a tie, rank it by the alphabetical order of the last name.
Oh, then you could put an order by clause in there.
Okay.
Yes.
Yes,
If you want
okay.
to break the tie, you
Yeah.
add it in the order by.
Yeah.
Okay, thank you.
Making the order by clause unique.
Yeah. That'd be a simple solution to that. Yes, sir.
If you actually wanted 5 and 6 different numbers, then you just change the order by in the rank to include extra clauses.
You could.
If you wanted to actually give a different number.
Well, then because they're aggregate functions in here, you're going to have to be careful with that. It might be possible.
It's possible by concatenating or adding to the sum of salary the row number.
Yeah, you could do that. Yeah. Yeah. But the functions themselves, according to the functions, 5 is the same. 10,000 is same as 10,000.
Believe it or not, I understand that 5 is the same as 5. I get that point.
All right, so there you can take those rows out. Okay.
So,
Yes.
and the understanding is that when we get finally ordered rows, when we'll get the rows, we'll be getting them in ordered rows, right? Rank
Yes.
2, 3, 4, 5, and so on.
You are getting them ranked by the sum of the salary descending. That's how they're ranked. And that's by default how it'll give it back to you.
Right.
Yes, by rank.
Because Oracle is lazy, you probably will get it back in that order. But you should
have
an order by if you want an order by.
Yes. As always, let me say this. Technically, if you want them back in a specific order, you must specify the order with an order by clause. That covers all examples from here in this whole presentation. There. Technically, to be correct, got to have an order by clause. These are so simple, it'll give them back to you in order. Okay. All right. You can specify how you want nulls treated, nulls first or nulls last, so you get your option. You know, some people want to see them first, some people want to see them last, so you get your option in how they're ranked and where they go in the ordering.
Can you use that with just a regular order by clause too? Nulls last, nulls first? Or only with ranking?
Just with the ranking.
Nulls last and first work in a regular order by clause.
Oh, they do. I learned something.
All right, there you go. That was something I didn't know. Okay. Now we're going to throw in another concept. Please do not confuse this type of partitioning with database partitioning. They are not the same. Okay? I usually think of these as buckets. Okay? So we are going to partition the data by department ID. Okay? So all those department IDs that are the same, we're going to put them in the bucket together. Okay? So you're going to partition it by department ID. And then for each one of those buckets, okay, and notice what I have down here. I have department ID in the group by clause. So by year, I'm going to put all the different departments into buckets, and then I'm going to do the aggregate function on it. Okay. Did that make sense?
Will that return the department ID, or for each department, will it start over?
Yes. Yes, because I'm partitioning it by department ID. Yes. So within that partition, then I will rank each of the things. Okay. Right.
What would be the result if you did not include the partition by, but it did include it in the group by?
I think you get an error.
There you get the overall rank, the group by the groups.
I believe you get an error in that case, because if you don't have these things synchronized properly, you do get a strange error message.
You always should put the group by wherever you have non-summarized columns, and those are the first two columns, so you would get a syntax.
Yeah, you'll get a syntax error. That's what I thought, because it doesn't know what to do at that point. Yeah, things are out of sync at that point. All right. Yes, sir.
So would this be a way of sort of breaking ties, like if you're to rank by state and then rank by city within state? So you'd have two numbers, so you'd have where every state sits, and then within the state where
Sure.
the city sits.
You could.
So that'd be,
Yeah, be a good way to do it. There you go. You answered your own question.
well, I'm not sure how it works. So I just,
All right. Cumulative distribution. This one's a little interesting. I put two things in the same statement. Okay. Cumulative distribution. Here, first we're going to rank them. Okay. Notice it's the same statement as before. I'm just adding something new to it. Okay. So we're going to do cumulative distribution. Partition by department ID. Okay. And this will give you, let's say that for that department there are 3 sums. Okay. And it'll give you 33%, 66%, 100%. How is it cumulatively distributed across that department? Okay. Does that make sense? So within that department, it'll give you the percentages that that thing was accumulation of. All right. Oh, that's the same thing, just ordered pretty, because when you do something like this, sometimes, you know, you get like this many decimal points. So for each of the examples, I give it to you one way, and then you get it this way, so that it formats it all nice and pretty with a percent sign, and it looks easier. Human consumable format. Okay. Percent rank Okay, it's similar, okay, but it uses row counts. So if you have a statement here partitioned by, again, department ID, it's going to tell you what percent, let's see how to say this. It's easier to, when my demo is working, then I can show you the actual output. Pardon me? That's true. It's relative to the grouping what percent it is. Okay? Instead of being a third of the total, it actually gives you the percentage of the total. That's true. It will always sum to 100 for each department ID. Okay, so if I got the first sum is 10 and the total was 100, it'd be 10%. Okay, does that make sense? So for each one of those, you get an actual percentage of the grand total.
Does it start out at a low percent and go up, or is that 100%
It starts at yes, it depends on the order by. Descending. So it'll put the highest percentage first and go down. Default is the other way, of course. Okay. So it would be ascending. So it is the percent of the total for that, in this case, partition of department ID. And again, there it is in human consumable format. Entile. You may go to the session bright and early Sunday morning with Bren. He was talking about entile. This is that function he was referring to. Okay? So you can say, take the data and split it into X number of buckets, essentially is all you're doing with it. Okay? And you get to specify how many buckets you want to split it into. So here, same query as before, taking the data by year, by department ID, getting a sum of the salary, and take those sums of salaries and split it into 4 different buckets. And it will number the rows that come back, either 1, 2, 3, or 4. It tells you which bucket that one was put into. Right? So it tries to split them as evenly as possible. Okay? Now, not everything is divisible by 4, so it will either be n or n plus 1 number of rows in each bucket when the buckets come back. All right? How many of you have used the old-fashioned row num and gotten unpredictable results with row num? Yes. And you pulled your hair out, right? Going, why did it do that? Well, there's now a function that you can generate a proper row number. Hallelujah. Okay. Thank you. So, same query as before. See my pattern here? Let's take, again, year, department number, sum of salary, and let's take the sum of the salary descending, and let's assign it a row number. And it will assign properly a sequential integer number to each of the rows returned. Sometimes that can be very useful. All right? So that's all there is to it.
Does it start at 0 or 1?
1. Good computer science question.
I have a question.
Yes.
If you put an order by on that, then would it be essentially the same as like that dense rank that you said earlier? Because the row num would be...
It will still assign a row number.
Could you use that row number as almost like a rank, the dense rank where there's no ties?
I guess you could.
Well,
What's really here is that, yes, row number, rank, and dense rank are all related in a way.
Yeah.
But the thing is how they handle the ties. row number, if there are ties, they will not get the same number.
Correct.
They will randomly get. If
That's
there
true.
are two that should be in third position, one of them will be 3 and one of them will be 4.
Yeah, you
cannot control which one.
If there's a tie, you don't know which one's going to get which row number.
Right.
But that might be good for like a manager report. They don't want to see 2 5s or whatever.
Yeah, you can do that.
Except if you have row number and dense rank, and you run into your first tie, then they're pretty much going to be out of sync forever after that.
That's correct.
If you got row number in the regular rank, you'll see the row number going up within the rank tie, but then when it gets out of the tie, they'll still match each other, right?
Correct.
Yes, you're correct. You're correct. Yes. In dense rank, they'd be out of sync forever. But in rank, they would catch up with each other.
Thanks.
Sure. Okay. Windowing. You've got a set of rows, and you would like to do something, and you're on, let's say you're on a particular row, and you would like to look backward, and or you would like to look forward from that row to do something. For example, I want, well, let's take a simple example. I am going forward, and I want to keep a running total as I go forward. How would you do that now? You add 2 letters in front of SQL, and you get PLSQL. Okay. But let's take that example first. I want to, as I go forward, I want to, on each row, I look at what my order total is, and I want to look back how far so that I get a running total. All the way back to the beginning. Okay, because the first row, there's nowhere to look back. On the second row, I look back 1 row. In the third row, I look back, I take my current value and look back 2 rows. In the fourth row, current value, look back 3 rows. And it just keeps going and going and going, right? Okay, with windowing, you can do that. Sounds almost frightening, doesn't it? Okay, so that's exactly what I've done here. This is a running total of salaries within a department. Okay? And notice what I've done here. What did I do right there? So I say sum it up by department and give me the total salary for that department. Okay? Now I go to the next row, to the next department, and I get its sum of salary. But I want to take that sum of salary and sum it with the previous sum of salary. So I have to sum the sums to get that to work, right? Because each row has a sum on it. And if I look back to the previous row returned, it's a sum as well. So I have to sum all of those sums up as I go forward. So I'm going to partition it by year. Okay, so I'll do each year in a bucket separately. Within each year, I'm going to do it by department ID. Okay, so I'll get a sum for each department by year. And for each one of those, I want the range to be unbounded preceding, meaning go back as many rows preceding me as there are. Go back to the beginning of all of the rows. And sum up all of those sums. And that gives you a running total by year as you go forward. Then when you change years, it starts over again. And you start a new running total by year.
Functionally, how would that differ from using a lag function?
How far are you going to lag?
But if your lag is running, your prior lag
So you're doing recursive. I don't.
That would require, if you wanted to do lag to simulate this, you would have to put it in a recursive resource.
Yeah, that's recursion.
Actually recurse.
And
Okay. Because with the lag, you cannot with lag get the previous result of lag and then the previous result of lag. That's not possible.
Because it's a result set not in the table.
That's correct. Yeah.
All right.
Yeah. Yeah. If you want to do that in PL SQL and do it recursively, PL SQL supports recursion. Yes. So this says go back to the beginning of time in that set, and in this case in that partition, right, which is a year, and you keep a running total of the salaries. Then when you switch year, you start over again, summing again, keeping a running total for the next year. Okay. Now, just because I could, this is one of those examples, just because I could, let's turn it around. All right, a running total goes ascending, right? Have you ever done a running total that goes backwards? With the grand total and then subtracts from it going down?
Checkbook.
Yeah, it's your checkbook. You can do it with this statement, okay? And all you do is the range is between the current row and unbounded following. So within that year, you take the first department and you have its total and you add to it all of the ones that come after it within that year. Then you go to the next row for the next department and you add to its sum all of the sums for the departments in that year that come after it. So the total starts out as the grand total for the year and starts decrementing as you go down. It's a decreasing running total. It's in reverse. I did it just because I could do it. Make sure it worked. And it works just fine. Yes, sir.
I noticed you got a group by department ID. Does that mean that running total is organized by per department?
That's correct. That's absolutely correct. By department within the year. So I'd get, in this case, department 10, grand total for the whole year, department 20 would be the grand total minus department 10s, right? In essence. But you get 10 through, or 20 through whatever comes after it.
If you don't have the group by department ID, then it would be an overall total variable.
Well, if you take it out here, I'm going to have to take it out here.
Yeah, so the order of the group has.
That's correct. That's correct. They have to be in sync or you get a syntax error.
At one point, all your examples, you are both using aggregates and analytics. You're doing a group by, and then you're doing analytic functions on the result of that group.
That's exactly right. That's exactly.
But just to make certain that people know that's not necessary.
That's correct.
Do analytic functions without a group by.
And I've got an example of that coming up.
Okay.
Yes, sir.
Specific question. We're assuming that salary is always positive, but we have debits and credits since you brought up the checkbook account.
That's correct.
That should be added or subtracted, so it's not always it's not always going down.
That's correct.
So
That's correct.
this work in it like an extra checkbook.
That's correct. On this, the assumption is since there's salaries, that no one pays to go to work. That's an assumption. Okay. And this one, I want to do a moving average. Okay. And I want to do it between where I am and 2 rows before me. So it's me and the 2 rows before me. So I can say, just like we did before, except say rows 2 preceding. Now, big warning here. When you get the first row of this result set back, okay, from this query, and it says, give me the average sum of the salary for my row and the 2 preceding rows, guess what? It's the same as my row, right? Because there are no 2 preceding. When you get on then the second row of the result set, you get the average of the sums of the current row and the 1 preceding because there aren't 2. It only really starts kicking in when you get to the third row, and then you get that row's average of the sum with the 2 preceding, and then it stays in sync until the end of the rows coming back. So just be aware that sometimes when you look at these data sets, you'll look at the first row and you go, what happened? And it's because there are no 2 rows preceding. So you have to know how many rows to look at before it becomes really the right kind of average that you're looking for.
Maybe I'm jumping the gun on your presentation. Is there a way of saying 2 before and 2 ahead?
Absolutely. Thank you for that beautiful lead in. Okay. And I switch tables here. I go over to the orders table, and I want a 3-month moving average that's centered. So I want 3 months prior, 3 months after. So I say range between interval 3-month preceding and interval 3-month following. So I'm looking at the previous 3 months. I'm looking at the future 3 months.
Does it count the middle month twice if you do that?
No, it does not. So
7 points, 7 data points there.
that's correct. This is 7 days. I say 6 months centered, but there's really 7 months in there. Okay, because you're considering the month you're looking at.
So it's the month you're on and 3 before, and the month you're on and 3 after.
That's correct.
All in the total.
That's correct. Yes.
So that's a
7-month moving.
7-month moving average centered on your month.
That's correct. You're exactly right. All right. Yes, sir.
So in this, you have the date as your order wise, so you can do 3 months of that date. What if it was on salary like your previous example? Then what are the other options you have other than the months or rows?
Ask that question again.
So in this, you have order by date.
Yes.
You are putting 3 months because it's a day.
Well, all right. For each row that comes back, you're getting the year, the sum of the salary for that month, and the average for that row 3 months prior and 3 months after.
From that row, and that row date is order date.
Yes, it's the order date.
I think he's asking, month is a keyword, and because it's ordered
date.
It's ordered by date. Oracle knows. Just knows because it's a keyword.
Yeah.
But if the keyword is number, what are the other options?
Oh, there's a whole bunch of options right here. Day, month, interval.
Is there any range or option for numbers? If the keyword is number.
Oh, ooh.
Like
2 rows.
Yes, the number of rows. You can say rows preceding rows.
Up $1,000 down, something like that.
I don't think so.
Less than greater.
Less than greater than.
I don't think so.
Okay.
Will you be covering difference between rows between and range between in your examples?
Let's see. That one was rows.
Yes, but are you going to talk more about the difference between rows between and range between?
Yes, thank you for bringing that. Rows, okay, you have to be very careful. you have to know how the rows are going to be returned, right? If you don't know, if you can't predict how the rows are going to be returned, rows can get you in trouble. Because you want to know which two previous rows you are looking at, right? Now, in this, can we fairly well predict which rows we'll get in what order? If you can, then this makes perfect sense. If it's not deterministic, then you can't get reproducible results. And that's beyond dangerous.
So in this case, if you had multiple hires in the same department on the same date, you wouldn't know exactly which rows. So if you had hired 4 people on the same date in the same department, you wouldn't know exactly which rows it was getting.
Well, this is done by year, by department. So in that case, you're okay.
But yes, if you had done that analytic function on employees table without the group by,
Then you're in trouble.
then you would have had some difference there.
You're absolutely correct. It has to be deterministic. You have to be able to determine, because otherwise you don't know which 2 previous rows you're looking at.
But could you go back one more? Go back one more in yet. Right. The range unbounded preceding here. Because the combination of partition and order by, in this case, is deterministic. It's unique because it matches those in the group by. Here, range unbounded preceding and rows unbounded preceding would give the same results.
Yes.
But if the order by there had not been deterministic, then range unbounded preceding and rows unbounded preceding does not give the same results. Rows would be non-deterministic. Range you would be deterministic. But range would also then, for those 2 that have the same, the ties, it would give the same result summing both of them, which probably would look different than what you want. My personal opinion is that you nearly always want to use rows and not range. Also because the optimizer with the range unbounded preceding, it does not know that this order by is deterministic. So with range, it actually has to look forward a little bit to find out whether it needs to include the next row. If I use rows unbounded preceding because I know it's deterministic, the optimizer can perform better because it does not need to look forward.
Yeah, makes perfect sense. All right. All right, so we got there. All right, before I move on, any question on windowing? Okay. It's a cool function. You look forward, look backward, or look forward. Okay, ratio to report. Here what I want to do is I want to find out what the ratio is to the list of things, okay? And this is basically a percentage. It is a percentage, okay? So I'm going to look at, and because I wanted the product name here, I actually did a join because otherwise you get a bunch of product numbers and you don't know what they are. So I want the product name, and for the orders, I take the unit price times the quantity. How many did you order at what price? Okay. And I'm going to add all of that up, and I'm going to then sum all of that. And notice here, what do I sum it over? Everything. That's right. Just sum it over the whole thing. Okay. So sum it up. Because I'm only doing one group by, right? So there's nothing to split it out by. So just sum up the whole thing. And then I want to see ratio to report. Okay. And what it does is it will give you a percentage of the grand total. So for that sum, of unit price and quantity by product name, it'll say like this is 3% or 0.03. That is 3% of the grand total. Okay, so in this case, it's just giving you a percentage of the grand total. Is what it's doing. That's handy.
Some be as a fraction, so you'd have to convert it to a percent of your 100%.
That's exactly right. You have to convert it to a percentage, multiply by 100, blah blah blah. Yeah, it just gives it to you as 0.03 whatever. And let me and on this example, when you run it, you have to show at least 4 decimal places. In this particular example, or a lot of them come out 0 because the numbers are so small. So someone asked about lag and lead functions. So let's take a look at this. Again, doing by year, sum of the salary. And I want to lag behind sum of salary by 1 row. Now, let's say you're in the middle of the result set that's coming back, and I'm going to start at the middle, and then I'll work to the ends. Okay? You would get the sum of the salary for that particular year. This line would give me the sum of the salary for the previous year. And lead would give me the sum of the salary for the next year, all on 1 row. So if you're doing some comparison, you could see what current year, previous year, and next year sums of salaries were, all on a single row. Yes, sir?
And when you say here, previous year and next year, well, it's more, would probably be more correct to say previous row and next.
That's correct. That's correct. And that's.
If there are missing years, it's not. That won't be. It'll just.
That's correct. That's correct. Because there may not be a previous year. And in this data set, that's exactly what you get. There are years missing. So you may not get an answer for everything.
Well, you will get. You'll just get the 1, 2 years.
That's correct. You get the wrong answer. It's the previous row. Yes, sir.
Say you did a Cartesian join to enable it to force having every year in there in his example. Would having those 0 values in there force a change in what it calculates this? Or would it go just to the next available true value?
If there's data in there with zeros, then it would sum it up.
Okay.
Yeah.
Well, yes.
So it would affect the numbers you're seeing there.
If you.
Yes.
What's it called? Densify your sparse data.
Yes.
Okay.
Then yes, lag and lead will pick the previous year because now you have some data where all the years are present. So,
Yes, sir.
In the lag, if it's the first row and you're summing a salary for a row that doesn't exist, will it return no or will it return 0? Is it smart enough?
It's smart enough. I think in that case, it'll return a null.
Okay. So
because there's nothing there.
So
there's no prior row in that case.
That's only for the very first row.
Yes. Yeah, it's only for the very, and that's why I said I started in the middle.
And the lead would be on the left.
Yes, and when you get to the last, then there is no other row to look forward to.
So I guess going back to what you mentioned earlier when talking about the group by at the bottom, does that only apply for that sum salary, not for the lag and lead?
It applies to this sum of salary right here.
No.
And then we're using this in here to say, looking forward and backward, what do I want?
The point here really is that when you combine the aggregates, group by, with the analytics, the lag and lead, what happens is that the aggregates, the group by, that's all calculated first. Then when it's
got to
done
be.
with that, then it starts the analytics.
It's
so the sum salary within the lag and lead, that's calculated as part of the group by first. then you have an intermediate result set there, and the lag and the lead will be applied on that.
That should be common sense, but thank you for stating that.
So the lag and lead, is that returning the previous year for a person or the previous hire date then?
It's based on hire date. See, right there. Just taking the year part of the hire date and grouping on that.
It returns everybody's salary for that year because of the group high.
Yes, returns everybody's salary because of this group high. Exactly right. All right. And since I have 3 minutes left, has anybody not seen case expressions? Good. Hallelujah. If you've ever written a decode statement that was about that long, when this came out, I was like, oh, thank goodness, because nobody could read decode statements unless you lined them up properly and did all this funky stuff in your formatting, and then your SQL came out this long. And so anyway, there's just an example of, a couple examples of case expressions. All right, so that, if you haven't seen it, then there it is. Because that's included in the data warehousing section and this data warehousing guide in chapters 18 and 19. All right. Questions? Okay, again, every single one of these examples, you can get to it through your app or out there online, and they only use those tables that are pre-built with the Oracle demos. So you can go back and you can run them all yourself, and you can see just cut and paste, and they should all work. I've done it 3 times now, and so far I saw one typo in there where I put a sum instead of an average, but okay. The statements are all syntactically correct and will execute.
Thank you.
Okay.
Thank you.
Thank you for coming.